All right, in this lesson, we're going to be looking at solving systems by what is called Gaussian elimination. So we've solved linear systems before using substitution, elimination, or graphing, and actually we learned Cramer's rule. But here, we're going to use what's called Gaussian elimination. So the concept is going to be a lot like the elimination that we've used before, but it's going to be written in matrices, and we're going to kind of negate the variables for a bit. So let's take a look at some ideas before we get to actually solving. The first thing is we'll look at what's called an augmented matrix. That's going to be related to a system of equations, as you can see below. So an augmented matrix is a matrix which the first n by n elements, so the first square, so this is 3 by 3, the first n by n elements are the coefficients of the variables of the system, and the last column is going to be the constants of the system. Now, before you put it in an augmented matrix, you want to make sure you have all of your variables on the left side in the order that you want them, and then the constants on the right side. And you can see here that you have an augmented matrix for this system of equations. So 3, 7, -1, 3, 7, -1. And the next column is 2, -4, 6, 2, -4, 6. And then the last one is 5. There's no y value, so 0 for y and -2. And then this last column you see is the constants. So just for practice, we want to put this system of equations in an augmented matrix. First, we want to make sure all the variables are on the left side in the order that we want, and the constants are on the right side. We see in this first equation that this z needs to go the other side, so we're going to squeeze this in here. We're going to subtract 4z from both sides. So we will have 2x minus 3y minus 4z equals -4. The second equation works out. It looks good, so we're going to write that 5x plus 4y minus z is equal to -7. And the last one, we have to add 1 to both sides, and we see that's -8x. There's no y term, so I'm actually going to skip a space because there's 0 y's. You don't have to do that, but it may help for later. And now we want to put it as our augmented matrix. So our first 3 by 3 terms or elements is going to be 2, -3, -4. That comes from these coefficients. Our second one is going to come from these. So this is 5, 4, -1. And the last one is going to come from these coefficients, which is -8, 0, 3. And then we put our constants on the other side here. So there is the augmented matrix. So that's just practicing putting it in an augmented matrix. We don't end there. There's more to do. So what we want to look at next is the elementary row operations. So when we have an augmented matrix, as we work through this Gaussian elimination, here's the 3 rules that you can use. Any 2 rows can be interchanged, so you can switch the first and second row or first and third row. Number 2, any row can be replaced with a multiple of that row. So you could take a row, multiply it by something, and then replace it with that new one. Or, and this is the one we use most often, any multiple of one row can be added to another row, and actually you can replace either row with that new sum, the multiple plus another row. In fact, you can add a multiple of a row plus a multiple of another row is also fine. So what we want to get to is what's called echelon form. Echelon form in that augmented matrix is when, now oops. These are just spaces. Now, we did a 3x4 augmented matrix for an equation with system of equations with 3 variables. Sometimes it will be even easier, and you'll have something that looks like this, where it's 2 equations with 2 variables. But regardless, the echelon form is when all entries below the main diagonal, so there's the main diagonal in the 3x3, here's the main diagonal in 2x2, all entries below the main diagonal are 0. So we want this, this, and this to be 0. If it were this 2 equations with 2 variables, you really just need to get this one to be 0. And this is helpful because it's going to be easier to solve. To demonstrate that, there's this next thing. It says, solve the following system of equations. Well, this is kind of set up like an echelon form matrix. It's not in a matrix form, but notice here in our second row, there's 0 x's. And in our third equation, there's 0 x's and 0 y's. So it's kind of like that triangle of zeros that was mentioned before. So notice this is easy to solve because for z, we can just divide both sides by 7 and we get z equals 2. Now that we know z, we can plug it in here. We have 2y minus 5 times z, which was 2, equals negative 11. We would add 10 to both sides, and that would give us 2y equals negative 1, so y equals negative 1/2. And then to find x, we can take z and plug it in here, and this y that we just found and plug it in there, and we have 3x minus 4 times y, which was negative 1/2, plus z, which was 2, equals 13. We got 3x plus 2 plus another 2 equals 13. We would subtract 4 from both sides. 3x equals 9, so x equals 3, and we have the solution to our system of equations, x, y, and z. So that example there was to show you that it's easy to solve once you have this triangle of zeros here. So what we're going to do now is we're going to do this Gaussian elimination, which really Gaussian elimination is to reduce an augmented matrix to echelon form. And then you solve it. So this is our first one. Be careful. There's nothing really difficult in these. It's most mistakes are made, if there are mistakes made, because of addition, multiplication, subtraction mistakes, or even just copying things incorrectly. So make sure you're careful. So what we're going to do is we're going to check this to make sure they're in the right form. All the variables on the left side, the constants are on the right side, so that's good. And so let's put this as an augmented matrix. Negative 2, 5, 2, 23. 4, negative 1, 2, negative 13. 1, negative 3, 6, negative 17. Now let's talk through what we want to do here. We know that we want to get these 3 spots to be 0. Now there's a little bit of an order that we have to follow here. We want to get these 2 to be 0 first. It doesn't matter, so you want to get these to be 0 first and second. And then this one we're going to get to be 0 last, or our third thing. And in order, so make sure you're paying attention, in order to get this third one to be 0, you have to use the last 2 rows because you'll have zeros there and you want them to remain 0. So let's go ahead and get started on this. I'm going to get rid of some of that stuff that I just wrote there so it's not messing us up. All right, so let's start by getting this 4 to be a 0. So what we are going to do here It's similar to elimination that we learned in the past. So in the past, we would, like if we were looking at this thing, that's not what I wanted. If we were looking at this, we would multiply the top row by 2 and add it to the second row. Well, that's what we're going to do. We're going to multiply 2 times row 1 plus row 2, and that's going to go in our second row. So the first row is okay. We're okay with -2, 5, 2, and 23. Our second row is going to be replaced with what we just wrote here. Oftentimes what I like to do is go ahead and write 2 times row 1 right up here in our matrix a little bit smaller. So 2 times our entire row 1. So 2 times -2 is -4. 2 times 5 is 10. 2 times 2 is 4. And 2 times 23 is 46. And so now I can fairly easily do 2 times row 1 plus row 2, because I have all the numbers right there. So -4 plus 4 is 0. 10 plus -1 is 9. 4 plus 2 is 6. And 46 plus -13 is 33. Now you don't have to make all those shapes around it. That's just so you can see what I'm doing. And then we're going to leave the last row the same. As you get better at these, you might have actually done the last row in the same step, but I don't want to do that quite yet. All right, so we have our first 0. Congratulations. Now we want to get this spot here to be a 0. Well, it's going to be kind of similar. We're going to use row 1 along with row 3. But this time, we're going to take row 1, and that's a -2, so we would want this to be a 2. So we can row 1 plus 2 times row 3, and that's going to go in row 3. We can rewrite our first 2. So -2, 5, 2, and 23. As I'm looking at row 2, I notice everything here is a factor of 3. So I'm going to multiply everything by 1/3. So I'm going to 1/3 times row 2 just to simplify that a bit. So that's going to be 0, 3, 2, and 11. And now I want to put my new row 3 in here, so I'm going to do what I did before, and I have row 1, but I'm going to do 2 times row 3, and I'm going to put that in here. So 2 times 1 is 2, 2 times -3 is -6, 2 times 6 is 12, and 2 times -17 is -34. And again, what that was, I was multiplying 2 by everything in row 3. And now I can do some additions here. -2 plus 2 is 0. That's what we wanted. 5 plus -6 is -1. 2 plus 12 is 14. And 23 plus -34 is -11. All right. Oh, I'm sorry, I did the wrong thing there. 23 plus -17. I don't know what I said, but 23. Oh, I'm sorry. Nope, that was right. I'm confusing myself here. 23 -34 is -11. All right. Next, we want to get a 0 in this location. Well, in order to do that, we're going to multiply the third row by 3 and add it to the second row. So we can keep our other 2 rows the same. -2, 5, 2, and 23. 0, 3, 2, and 11. And then this last row, we're going to multiply it by 3. So what we're going to go in our third row, it's going to be row 2 plus 3 times row 3 is what we're going to do here. So we want to do 3 times row 3. I'm going to write those answers here. 3 times row 3. So 3 times 0 is 0. 3 times -1 is -3. 3 times 14 is 42. And 3 times -11 is -33. So we're going to add those. 0 plus 0 is 0. 3 plus -3 is 0. That's what we wanted. 2 plus 42 is 44. And 11 and -33 is -22. And so we got down to echelon form. So once we do that, we go ahead and we rewrite this back in matrix or in equation form. So we have -2x plus 5y plus 2 equals 23. We have 0 x's. So I'm just taking these rows and put them back in equation form. So 0 x's plus 3y plus 2z equals 11. And then our last row here is 0x, 0y's, 44z equals -22. And just like we did before, this is going to be easy to solve. We would divide both sides by 44. So z is -1/2. We go ahead and put that into the second equation. So 3y plus 2 times -1/2 equals 11. This right here is -1, so we can add 1 to both sides. And we get 3y equals 12, which means y equals 4. And then we take z and y and put it back into the first equation. So -2x plus 5 times y, which was 4, plus 3 times plus 2 times -1/2 equals 23. -2x plus 20 minus 1 equals 23. That's 19, so we'll subtract 19 from both sides. We get -2x equals 4, so x equals -2. Our answer to the system of equations is -2, 4, and -1/2. So that's Gaussian elimination. It does take some time, but if you remember back to solving 3 equations, that also took a long time. The nice thing about this is you can, since we're just working with numbers and operations, you could actually program something to solve this for you. So let's go ahead and look at our last question, if I can find it. Here it is. Solve using Gaussian elimination. All right, here we go. We first check to make sure all the variables are on the left and the constants are on the right. They are. So let's go ahead and copy these. 2, 3, 5, -9. So there's the augmented matrix. All right, now that we did an example, I'm going to show you what I would normally do with stuff like this. All right. So first of all, this one is different because we're going to have to multiply the first row and the second row by something to be able to eliminate. So we have a 2 and a 3. So what I would do is I would take 3 times row 1, and I would subtract. So this is the first time we're subtracting, but we can do that because subtracting is the same as adding the opposite. And in order to get a 0, we're going to subtract 2 times row 2. That will give us a 6 in this position and a 6 in this position, and we're going to subtract them. So what I mentioned before, I'm going to go ahead and write these things in here. So 3 times row 1. I'm going to take everything in row 1 and multiply it by 3. That would be 6, 9. Make this a little larger for you. 6, 9, 3 times 5 is 15, and negative 27. And then for this other one, we're going to take 2 times row 2. So 2 times 3 is 6, 6, 4, and 2 times 4 is 8. Now, I am leaving the first row the same. 2, 3, it's a little small there. 2, 3, 5, negative 9. My second row, remember I'm going to do subtraction, so 6 minus 6, so I'm just subtracting the oranges now. 6 minus 6 is 0. That was our goal. 9 minus 6 is 3. 15 minus 4 is 11. And negative 27 minus 8 is negative 35. All right. Now, I am going to do something else in the same step, because I notice if I take my first row with my third row, that's a 2 and a 5. I want to eliminate the x so I can multiply the top row by 5 and the bottom row by 2 and subtract them. So I'm going to do that at the same time. I can do 2 steps here. So we're going to do 5 times row 1 minus 2 times row 3. I'm going to do the same thing. I'll use green this time. But 5 times row 1. Oops. 2 times 5 is 10. 3 times 5 is 15. 5 times 5 is 25. And negative 9 times 5 is negative 45. And then I'm going to do 2 times row 3. 2 times 5 is 10. 2 times 2 is 4. 2 times 3 is 6. And 2 times negative 1 is negative 2. And now I can combine those green ones to get my third row. And once again, we are subtracting. So 10 minus 10 is 0. 9 minus, 15, we're doing the greens. 15 minus 4 is 11. 25 minus 6 is 19. And negative 45 minus negative 2. Negative 45 minus negative 2 is like negative 45 plus 2, so that is negative 43. Great, so we got our first 2 zeros. Now we want to get our last and final 0. So looks like we'll need to take, remember we have to use the ones with zeros. We might be tempted to think, oh, I could do the first row and second row and just subtract. But realize if I did 2 minus 0, that's going to give me a 2 back in this position, and I need to keep a 0 there. So even though it looks nice with 2 3s, we need to use the second and third row. And so it looks like we'll have to do 11 times row 2 minus 3 times row 3. All right, well, that will be interesting. We got some bigger numbers here. We'll keep 2, 3, 5, and negative 9. We'll keep 0, 3, 11, and negative 35. And now we're going to do some multiplications here. 11 times 0 is 0. 11 times 3 is 33. 11 times 11 is 121. And 11 times 35 is 385, negative 385. And then we want to take 3 times row 3. Make sure you're careful with your multiplications here. If you mess up, it's really going to throw things off. So we have 3 times 0 is 0. 3 times 11 is 33. 3 times 19 is 57. And 3 times negative 43 is negative 129. All right, Let's subtract these, because we are subtracting. 0 minus 0 is 0. 33 minus 33 is 0. Those were our two easy ones. 121 minus 57. That is 64. So this is 64 here. And then this is negative 385 minus negative 129. So it's going to be plus. So we have to do 385 minus 129. That is going to be 256, but it's going to be negative 256. My guess is most of you would have just done that on your calculator, and that is okay. All right, we have it in echelon form. We have our 3 zeros here. In fact, yeah, so from here we can change it back to our system of equations. So we're just writing our equations, putting x, y, and z back in here, and put my little line there. We have no x's, 3y plus 11z equals negative 35, and no x's or y's, so we have 64z equals negative 256. If we divide both sides by 64, we are going to get negative 4. Now we can put that negative 4 into the second equation, so we have 3y plus 11 times negative 4 equals negative 35. That's negative 44, so we're going to add 44 to both sides. That's 3y equals 9. So y equals 3. And then we're going to come back to our first equation and put both y and z in there. So 3 times the 3 here plus 5 times negative 4 equals negative 9. We have 2x. This is 9 minus 20 is negative 11. Add 11 to both sides. You get 2, so x is equal to 1. So our solution is 1, 3, and negative 4. And that's Gaussian elimination. We did 3 by 3 examples. You can also do it with a 2 by 2, which is a bit easier because you just have to get that 1, 0.